Hi guys, it's Miss Holzer again. So for Wednesday, Thursday, and Friday this week, you guys are going to be working on a long lab at home. Now, parts of it have been changed, but I'm hoping that you guys have enough of these supplies at home that you're able to do it yourself. So I'm going to show you the setup for the lab. We're going to walk through the lab, and then you guys are good to actually complete the lab on your own. If while I'm going through the lab, you realize you don't have some of the essential materials, I'm actually going to do the lab. And you can watch me do the lab and collect data while watching the video, and that can be your way of doing the lab instead. Okay, so let me share my screen with you guys. So we are looking for the document in Schoology in your energy folder. It should be that top document. It's called Does Mass Affect Energy? So first, let's read through the goal to determine if the mass of a ball affects the amount of energy it has. So the background, energy is the ability to do work. Objects can have stored or potential energy when work has been done, such as raising an object into the air, or based on their position, such as sitting on top of a hill. Potential energy is calculated based on the object's mass and its height. Potential energy changes to kinetic energy when the object moves. One example is holding a stretched spring, potential energy, and then releasing it, kinetic energy. Another example is holding a box above the ground, potential energy, and then dropping it, kinetic energy. Kinetic energy is energy that results from an object's motion. Kinetic energy is calculated based on the object's mass and velocity. All forms of energy are measured in joules. So, pre-lab questions, make sure you answer them in complete sentences. Give an example of when energy is used. Number 2, write the formula for calculating potential energy, including units. Number 3, write the formula for calculating kinetic energy, including units. What is the independent variable in this experiment? Number 5, what is the dependent variable in this experiment? Of course, mirroring the questions and answering in full sentences. Number 6, write a scientific question in the correct format. Number 7, what are 2 control variables in this experiment? And number 8, write a hypothesis in the correct format, including a because statement. So all you need are 3 balls of, at least 3 balls. If you want to do more, that's fine, of various sizes and masses. So I've got a giant marble, I've got a golf ball, I've got a ping pong ball, I've got a wooden ball, and I've got a small metal ball. If you have a tennis ball, a basketball, anything that's round, basically, you can use for this lab. So you need to find 3 round things. The next is you want to make an inclined plane, a ramp, anything that's slanted. So I luckily have a piece of wood in my house that I'm not using that I'm going to show you I turned into a ramp. But you could use a book, like a long book, and just turn it into a ramp, really whatever you have. You need some tape. You need a stopwatch, which you have on your iPad. You need a meter stick or a ruler. Now, you might not have that. So here's what I did instead. I measured the length of your iPad, and that iPad is about 27 centimeters long. That means you can use this iPad kind of as a 20 centimeter long ruler and use that instead. You need some kind of scale. Now, this might be the thing that you might not have. If you don't have a scale, then watch this video in entirety, and I will actually be using balls of different masses. I'll show you the masses, and then you'll have to collect some time data. And then you need like a Sharpie or a pen. So let me show you why. So we're gonna go through the procedure. We're gonna start by writing a description of each type of ball, a small metal, a large metal, etc. So for example, right, I've got these 5 balls. So one thing that I would do, as an example, I'll put it in red, I would write golf ball, right? That's this type of ball. And you can see it's in the left column, which is right here of the data table where it says description of ball. If you're only doing 3 different types of balls, only fill in 3 rows. You'll notice I have 5 options, which is great because I actually have 5 balls that I want to do this experiment with. You don't have to do 5. You must do at least 3. Now, using a scale, you want to measure the weight in pounds of each ball. Now, you might be thinking pounds is a curse word in our classroom. However, we need to know the weight in pounds to turn it into newtons. So I've got a little tiny food scale here, which is great for my smaller balls. If you've got a basketball or a soccer ball or something like that, you can use a regular scale like you would step on at home. I am not going to do that because I'm going to use these small ones. So if you don't have any balls at home, I'm going to actually give you the masses and make sure you fill them into the data table. The first is going to be this golf ball. This golf ball has a mass of 0.10. So here's the thing. 0.10 is the mass in pounds. Now, if you're looking at step 2, I want to convert it into kilograms. And to do that, I need to take that number, 0.10, and multiply it by 0.45. That's the conversion rate. So let me show you what I'm typing into my calculator. 0.10, right? 0.10, which is the mass, which is the weight of the golf ball in pounds, times 0.45. And what I got was 0.045. Now that is what goes right here into the mass of ball in kilograms. So once again, I'm filling in red as examples. Okay, now I'm gonna do it with the rest. So the golf, I'm gonna do a ping pong ball. And everything that I'm filling in red, you don't have to fill in. You only have to fill it in if you don't have any materials at home to do this with, and instead want to use the materials that I'm going to do in this video. If you have your own materials, that's what you should be filling in here. So let me find the mass of this ping pong ball. Come on, you can do it. This ping pong ball has a very light weight. It is 0.004. And to turn it again into kilograms, times 0.45. That's going to get me this number. So here I'm going to write 0.0018. That's its mass in kilograms. Okay, I'm going to do the next one. So now I've got a wooden ball. So what would I write here in description? What should I write? Wooden ball, if that's what you said. Great job. Wooden ball. Now, let's find its weight. This wooden ball has a weight of 0.011. How do I turn that into kilograms based on what we did for the golf ball and the ping pong ball? If you said multiply times 0.45, you are correct. And this should be our answer. So I'm going to fill that in for the mass of that, 0.00495. Good. Okay, next I have a metal ball. So once again in the description, what should I write? Metal. Very good. Metal ball. And now I need to find the mass. So let me get my scale ready. Okay, the weight of this metal ball is 0.062. Okay, once again, I'm going to multiply that times 0.45, and that gets me this mass in kilograms, 0.0279. You can see where I'm filling it in right in the data table here. Now, the last type I have is this glass marble. So what can I fill in for the description of that one? Okay, glass marble. Okay, let me find the weight. So the weight is 0.046. I want you to change that into kilograms. And then when you're ready, press play and check yours against mine. So if you said 0.0207, then you are correct. That is the weight. So now you need to make your inclined plane. So let's see. How do I? Okay, we're going to play around a little bit. So I have this staircase in my house. Right, can you see? Yep. So at the bottom of the staircase, I have this piece of wood. Now, all I did was I took that piece of wood and taped the top of it. And that way it's on an angle. I'm going to show you right here, right? It's on an angle. Now, if you don't have wood at home, why I have wood hanging around, I don't know. But if you don't have wood at home, use a book and slant it also. So that's step 3. Now I taped it to the top of I taped it at the top so that it stayed put on the staircase. You can see right there. Then from the bottom, I put 2 pieces of tape. Now I've got a meter stick laying around, and you might not. That's okay. Right? I've got a piece of tape at the 50 centimeter line here. and I've got a piece of tape at the 100 centimeter line here, 100 centimeters from the bottom of the ramp. And I wrote on them 50 centimeters and 100 centimeters. So that's where your iPad might come into play. You might not have a meter stick or a ruler hanging around. Use your iPad, which is about 27 centimeters long, and just under 2 lengths of your iPad, put your 50 centimeter tape, and just under 4 lengths of your iPad, put your 100 centimeter tape. If you're a little off, then that's okay. We're gonna make do with what we've got. So now, as it says, we're up to step 5. For each ball, measure the time it takes to reach the 100 centimeter mark. So if you've got your own balls at home that you're doing this with, you're all set up and you're good to go for the lab. If not, keep watching, and we're actually gonna be collecting some time trials. So let me set this up over here so that you can see. I'm gonna stop sharing for just a second. Okay. Now, on your iPad, right, I'm gonna say 3, 2, 1, go. And when I say go, you wanna start your timer. And when it hits this line, you wanna stop your timer. This line of the 100 centimeters is our backup line, okay? But that's only if we can't make it to 50 centimeters. So let's do the golf ball first. I'm gonna put the golf ball at the top of this ramp. And I'm gonna say 3, 2, 1, go. Start your timer. And you're waiting, and you're gonna stop your timer when it hits here. Do the whole thing. Beautiful, okay, here's my start, here's my stop. Ready? 3, 2, 1, go. Okay, now we're gonna do 3 trials as always. If you're at home and you're collecting this data with a timer, make sure to put your data into your lab. I'll show you where, so let's screen share again. So you wanna put that time that you just collected right here. We're gonna do 2 more trials of the golf ball, and then your average time goes right there. Okay, so here we go. Here's the ball. 3, 2, 1, go. Right, so we're making sure to stop our timer as soon as we get to the 50 centimeter line. One more time. And if I'm moving too fast, just pause the video and start whenever you're ready. 3. Oh, I guess I better fix that, right? That's why we have tape at the top. That to help hold it up. Well, this is science class, all right. That should help hold it up. Okay, ready? So we're gonna collect our 3rd set of data for the golf ball. 3, 2, 1, go. Okay, next we're gonna do the ping pong ball. Once again, please make sure you pause this video as much as needed. Ping pong ball up top. We're gonna do 3 trials. Ready? 3, 2, 1, go. Okay, ready? 3, 2, 1, go. And last trial. Here we go. 3, 2, 1, go. Oh, no. Stop. Reset it, reset it, reset it. Here we go. 3rd trial for real. 3, 2, 1, go. Okay, next is the wooden ball. 3, 2, 1, go. Okay, trial number 2 for the wooden ball. 3, 2, 1, go. Okay, trial number 3 for the wooden ball. 3, 2, 1, go. Okay, we're gonna do the metal ball. Trial number 1. 3, 2, 1, go. Oh, it hard. Okay, trial number 2 for the metal ball. 3, 2, 1, go. Okay. Trial number 3 for the metal ball. 3, 2, 1, go. Okay, last one is our glass marble. Trial number 1 for the glass marble. 3, 2, trial number 1. 3, 2, 1, go. Trial number 2 for the glass marble. 3, 2, 1, go. Okay. Last trial for the marble. 3, 2, 1, go. Okay, so I'm going to go back to screen share so that we can continue going through the lab. So we have now collected, all of these time trials, right? 3 trials for each type of ball. So how do you find the average for each? If you said, add these 3 up and divide by 3, you're right? You add up the amount of trials we did and divide it by the number of trials. So I'm gonna take these 3 times that you guys just recorded, add them up, and then divide that by 3, and you'll get your average. Now, this is a long lab, which is why I'm giving you until next Monday to do it, which means that we should be doing a piece of this lab on Wednesday, a piece on Thursday, and a piece on Friday. So this might be a good time to take a pause for Wednesday. I'm gonna keep going through, and you can always restart this video on Thursday and then finish it on Friday. So let's take a look at what we're doing next. Next, it says we need to calculate speed. So it says you need to write the equation for speed below. And it says you might need to refer to some past notes or previous labs. Once you've put the equation for speed in, and we don't need units, just speed, we need to actually calculate. So once again, if you only did 3 types of balls, you're only gonna have 3 rows filled in. If you did 5 or even 4, right? However many rows you filled in is how many rows you fill in here. All I'm doing is taking these names, golf ball, ping pong, etc., and rewriting them right here. Now, the distance, as it says, is 50 centimeters for each type of ball. Now, we don't want that in centimeters. We want 50 in meters. So if it's 50 centimeters, how many meters is that? How do I convert that? So remembering our conversions, we move our decimal once, twice, from centimeter to meter. That should get me 0.50 meters. That's the same for all of them. All of them have moved a distance of 0.50 meters because they all were recorded for 50 centimeters. So we're gonna put that same distance in all of the trials. Your time, you're just gonna copy and paste these average times right here into time and use them to calculate for speed. Next, let's take a look. You want to use the equation from your pre-lab. In particular, we're looking for the equation for potential energy, which is pre-lab question 2. Use that formula to calculate potential energy when they're at the top of the ramp. Now, to do that, you need the mass. Now, we already have the mass. If you go back to this table, these are the masses of the 5 balls I did. You might have different masses. For me, I'm just gonna copy and paste those 5 and put them right here. Then I'm gonna plug in acceleration due to gravity, which we know is always the same everywhere on Earth. What is the acceleration due to gravity that we've been plugging into our potential energy problems? If you said 9.8, you are correct. That should be the same for all 5. Now the distance should also be the same for all 5, but in this case, if you read the directions, it says your distance is the height from the top of the ramp to the ground. So I'm going to take my ruler again, or maybe my iPad, and I'll demonstrate how to find that. And I want to actually find the distance that, right? So this is not about how far it actually moves. It's about how far above the ground it is, which would be the distance from the top of the ramp to the floor. So to do that, let's use my iPad as my measurement tool, right? So this would be 27 centimeters, right? And then I've got about an iPad and a half. So I'm gonna eyeball it, and I'm gonna say that it's 35 centimeters. Now each ball was the same distance above the ground, so it should always be the same. However, once again, we don't want this in centimeters. We want this in meters. So just like I converted last time, how do I convert this 35 centimeters into meters? Think about how we did it right here. So just like last time, we're going to move the decimal place twice, making this 0.35 meters. That should be the same distance for all 5. Then you use your masses, the acceleration, which is the same for all 5s, and the distance, which is the same for all 5, to calculate potential energy. Next, we need to calculate kinetic energy. That's pre-lab question 3, right? Using this equation for kinetic energy, we need to do a calculation. So once again, we already have the same 5 masses. We're just copying and pasting. The speed, we already have 2, right? Because you calculated speed right here. So you're going to copy and paste those, and you're going to plug in those numbers to find kinetic energy. We're going to be creating 2 graphs. The first graph is going to be for your potential energy, showing how mass affects potential energy. Make sure each axis label, both mass and potential energy, have a unit. And make sure that you're putting, if you're using Create a Graph or doing a hand graph, make sure you're putting them in from lowest to highest mass. They must be in order, or else your graph won't turn out right. You're going to paste a picture of that graph, whether it's Create a Graph or by hand, to the end of your lab where it says paste graph number 1 below. You're going to do the same thing with graph number 2. This time it is mass and kinetic energy, okay, our final data table. Once again, using all of that data, putting it in order from the lowest to highest mass, creating a graph, and pasting it down here where it says paste graph number 2 below. Then we've got some post-lab questions. Does mass affect the potential energy of a ball when it's sitting on top of a ramp? Provide evidence. You know I need 2 pieces of comparative evidence in full sentences. 2, does mass affect the kinetic energy as it rolls down the ramp? Use evidence, use data from your data table, 2 pieces of comparative evidence. Which affects kinetic energy more, mass or velocity, and explain your answer. And then a challenge. Do a little research, find the gravitational pull on the moon, and recalculate the potential energy of each ball if this lab had been completed on the moon. And then we've got our checklist, and that's it. So this was a long one, which is why I'm saying this is not going to be due until Monday, the 30th. If you guys have any questions, then we are going to be meeting in person for about 25 minutes per class on Thursday, the 26th, and I'm happy to take questions then. If you have any questions after that, please feel free to email me or message me via Schoology. Looking forward to seeing you guys tomorrow, Thursday, the 26th. Bye.